It's a city located approximately 30 kilometers south of Milano. So it's very well connected with the rest of the country. There's a train every 20 minutes connecting Pavia to Milano, which is, of course, the hub of all the traffic transportation system. Pavia has a very old history. It was founded by the Romans, but then was conquered by the barbarian, the Lombards, and you can find many traces of the barbarian time in the city. There is a nice river, which is the reason why Romans, Lombards, and others later on occupied Pavia. The river is called Ticino, and it's very long. It's the fourth in Italy. There are a number of interesting buildings in Pavia. What you see there on the left is the dome, which is special because it has an octagonal plant, and that's very rare. And the building that is on the poster of the Discourse event is on the other side, on the back of the dome. So we are on the back of the dome, precisely. There's also a very nice monastery very close to Pavia, 8 kilometers from Pavia, which is the one that you see on top. So definitely, if you want to see sightseeing, there are a number of attractions in the city. But Pavia is almost, Sunny, can you move to the next slide? Pavia is also famous for its university. Nowadays, of course, Milano is very famous for the university system, but this is quite recent. Universities in Milano were founded approximately 100 years ago. Before that, people also from Milano went to Pavia to university, because the university there has been founded in 1361. It's one of the oldest worldwide. And it has a strong, this is relevant for us, it has a strong tradition in biology and medicine. It is in Pavia that Lombroso did some of his work on the criminal mind. It is in Pavia that Camillo Golgi described the black reaction of neurons, for instance. And there's a very nice museum of the history of science in Pavia that you might want to visit. Sandy, can you move to the next one? The meeting will be hosted by my institution, which is actually not the University of Pavia, but a different, smaller university called University School for Advanced Studies, short form USE, which is an institution model after the École Normale Supérieure in Paris. It's a small university devoted to the training of a small number of talented students. It's a public university, and with a strong focus on research. And within this institution, I direct the NEP lab, the Neurolinguistics and Experimental Pragmatics lab, that I was able to found thanks to an ERC grant, which is called Promenade, Processing Metaphors, Neurochronometry, Acquisition and Decay. And the core of the project is metaphor that we are examining in development, in decay, in the brain correlates. So we are looking at the whole lifespan, the acquisition, but also the degeneration of disability. And of course, we are considering schizophrenia as one of the populations in the project due to what we all know under the label of concretism. And it is on this grant that I will sponsor cover some of the cost of the meeting, like the lunch that will be offered to the participants and the coffee break. But the event will be co-organized with Marta Bosia. Can you move to the next slide, Sunny, please? And Marta is a psychiatrist. I don't think she made it in time to join now. because she had another appointment. But Marta is a psychiatrist, and we've been working together on the topic of language in schizophrenia, particularly on pragmatics in schizophrenia. Marta works in Milano. This also tells you how close the connection is between Milano and Pavia, at the Vita Salute San Raffaele, which is connected to a clinical unit that is devoted to a number of investigation and, of course, care. But I would say that the main thing there is cognitive rehabilitation. They have a strong background in COGREM. And in this context, we try to introduce in the clinical practice and care also the assessment of language and pragmatics, and we try to introduce also the rehabilitation of pragmatic skills in patients. She will organize the meeting together with me because we will take the opportunity of this event to, let's say, foster the Italian chapter of the Discourse Network and improve the collection of data also on our language. I hope to see you all there. I hope that the participation will be high, and thanks for the attention, and thank you, Claudio, for the time you gave me and that I stole to your presentation. Thank you.
Thank you so much for the introduction. I'm sure that's made everybody here excited to attend and to join us in Pavia. So we're still planning the program for that satellite meeting. We plan there will certainly be an overall of discourse as well as a presentation from our Italian colleagues to learn more about the work there. And then on the discourse end, we're planning to organize some talks around the working groups that we've recently started. So the goals of the working groups, as well as related projects and works, perhaps like symposium talks, and that could be, relevant. And there will be a small poster session as well. So, I look forward to hearing more from us about those details, I suppose. So yes, thank you again to our speakers, Claudio and Rui, for allowing us to take up some of your time. And I'll let Tuche introduce our speakers, and we'll get started with that.
Hello, everybody. Welcome to our second Discourse Seminar of Fall 2023. Today, we'll have presentations from Claudio and Rui. But first, please let me introduce Claudio and Rui. Claudio's primary research focus lies in exploring the semantic and referential meaning within speech, particularly within narrative structures. He specializes in studying these aspects in clinical populations afflicted with schizophrenia and related psychotic disorders. His objective is to unravel the functioning of diverse linguistic mechanisms in these individuals, while also drawing comparisons with neurotypical counterparts. To accomplish this, he employs natural language processing, computational tools, and predominantly work with Python programming. And Rui is taking his doctoral program at Universitat Pompeu Fabra, Barcelona, under the supervision of Dr. Wolfram Hinzen and Dr. Nuria Bell, and granted by the China Scholarship Council. His research interest revolves around the application of natural language processing in cognitive diseases, particularly on how language and brain function change in cognitively atypical populations using automatized approaches. Under further into how changes in these two domains connect to each other, the initial focus was on Alzheimer's disease, but has since been expanded to include other types of dementia, such as progressive primary aphasia and schizophrenia. These studies theoretically and practically endorse the deployment of language and brain imaging in automatic warning for early onset and disease relapse. And I think we can start. Shall we start? Claudio will present first. Are you ready, Claudio?
Yes.
Okay,
Can
thank
you
you.
see? Yeah, can you see
Yes,
the?
we
Okay,
can
perfect.
see right now.
Perfect. So, okay, thank you for having us here today. I see many familiar faces. And well, I'm going to start talking about referential and conceptual meaning in psychosis. Let me minimize. Okay, I can minimize this. And this is the outline. So I'm going to talk about conceptual and referential meaning, different things. Then I'm going to present a study we did on referential meaning. Then I want to go from referential to conceptual meaning and how we use some semantic similarity measures in this data, Chilean and Spanish data. And then we want to understand if there is a relationship between referential and lexical conceptual meaning. And finally, try to apply some semantic similarity measures in a larger German dataset. So we have these two distinct components in the meaning of any utterance. So for one side, we have a lexical conceptual meaning. This is something we use to describe entities in the world when we talk. So this relies on our semantic knowledge. For example, cat. So we know what cat is. And for the other side, we have the referential meaning. And this is how conceptual meaning is related to entities in the real world. So it depends on the grammar and the distinction it mediates. Specificity, for example. So I can say a cat, that cat, or the cat, saying different things. Or doing co-reference. For example, her, it, or both. For example, her cat. So it was really interesting to know how could these two components of meaning be related in psychotic discourse, and if they are related. Okay, so in psychosis, referential meaning have been found specifically deteriorate in individuals with schizophrenia, with some unclear reference making discourse difficult to follow. Also, there are some anomalies in pronominal reference in schizophrenia. So this is a study of referential meaning I want to present you. This was published in the Schizophrenia Bulletin supplement of language and psychosis. And I will give you an overview over the main results of this article. So in this article, we want to study the control over references in a speaker with schizophrenia, but also we had a clinical high-risk group. We had 60 Chilean Spanish speakers, so 20 controls, 20 clinical high-risk, and 20 schizophrenia. And all the clinical interviews were about 990 words on average. So they were very comparable to the number of words. So what we did, we were very inspired in the work of Natalia Mota of the speech graph. And we also did some speech graph, but instead of using word as nodes, we use noun phrases as nodes. So each node here in this speech graph, in this graph, is a noun phrase. So let's zoom in. So suppose we have in this graph utterance saying there was a man on the street waiting for someone. Later, a woman met him. Although they went to a cafe, she seemed to be busy. So we can plot this in a graph. So everything in bracket is a noun phrase, but in the nodes, we don't have, well, in the nodes we have noun phrase, but we have two different noun phrases. Some noun phrases refer to entities, recurrent entities. So for example, the man here or the woman, and they are recurrent because we come back to them when we say him. So a man on the street waiting for someone, later a woman met him. So we come back to the man. And then we come back to the woman using the pronoun she. So as we trying to understand referentiality, we are focusing more on these nodes that refer to entities, recurrent entities. So let's use the same example. So suppose a square is the man, and we have a triangle for the woman, and anything else is going to be an X. So we have the man, something, another noun phrase, then the woman, then the man again, another noun phrase, and then the woman again as entities. So we can calculate a topological distance, which would be the number of nodes between an entity and the co-referent. So in this case, we have 1, 2, 3, 4. That would be the distance to record, to come back to the man. The same with the woman, we have another recurrence here. So we can do typical things we can do in graph. For example, we can calculate the degree of the graph, the total number of recurrences, and this is some of the things we did. So we found that the total number of recurrences, so you can think as the sum of the degree of the nodes. So if you look at the nodes here, they have at least 2 edges here, but they can have more. If they have more, it's because they come back to the entity. So the total number of recurrences, and this is divided by the number of words, turn out to be significantly higher in schizophrenia than in controls or than in clinical high risk group. Also, we found an increase in the density of noun phrases. By density, I mean the number of MPs divided by the number of words. So we have a significant increase in the density of the MPs related to compared to clinical high risk, and also control versus controls. And we also found a correlation between these two things. So the density of MPs is correlated, strongly or significantly correlated with the number of MPs is correlated with the number of recurrences. So as we can see here. Okay, and we can see, for example, the density of MPs is more to the left, to the right. And about the topological distances, you can see here, for example, another example of the man and the woman. I could calculate, for example, this distance here between this square and this square, and between this square and this square, and we calculated some maximal distances. So, for example, for the man, we have a distance here of 4, but from here to here we have 11. So the maximal distance for the man is 11. And for the woman, the triangle, the maximum distance is 4. So we calculate the mean of the maximal distance, and this is significantly higher in schizophrenia than controls. The same if we calculate only the max of the maximal distance. So in this case would be an average, in the left would be an average of 11 and 4, and in this case would be the maximal value, so 11. So imagine we are doing this with all the reference, with all the recurrent entities in the speech. So an interim summary. Schizophrenia produces more noun phrases, more than the clinical high risk and more than controls. And mainly this happens because there are more recurrences in total in schizophrenia. So if you look at the graph and you add all the degrees of the recurrent entities, you obtain a larger number in schizophrenia. And also we know that there is this correlation between the total number of recurrences and the density of MPs. So because of this, because we have more MPs, so you can remember how is the graph, this leads to a topological distance, a larger topological distance between recurrent entities and its coreference. So you can think as why the topological distance is larger is because there is a lot of material between the entity and the coreference. And this material is other MPs or even other MPs, but those MPs can be recurrent entities or non-recurrent entities. So there is some interference within each other, creating some entanglement between this referential thread we have in the speech. Okay, so we want to go transition from the referentiality to conceptual meaning. And we first ask, is there a relationship between these two concepts, or should there be a relationship between them, these two kinds of meaning? And for example, we know that in schizophrenia, in first episode of psychosis, there is an increase in semantic similarity in this work of María Francisca Alonso Sánchez. But following the broader conceptualization of loosening of association in schizophrenia, many studies have explored these NLP tools like semantic similarity with the prediction of a decrease in semantic similarity. But loosening of association also could predict the opposite, predict increase in semantic similarity, reflecting a greater associativity between different concepts or a shrinking of the semantic space. And this would be consistent with some data from Chang, an article to appear in Chinese, indicating some increase in semantic similarity. And you can see in the next talk, Rui is going to talk about this. So in this same data, in Chilean data, Chilean Spanish data, here we found a non-significant increase in semantic similarity, but, okay, non-increase from the affinity matrix. And affinity matrix, I have to say here, is there are different ways to calculate semantic similarity. So for example, calculating the semantic similarity between correlative content words. But also you can take all the content words and compare all of them in pairs and then obtain the average. So this is the value we have here. So the average of all the comparisons in semantic similarity was higher but not significant in schizophrenia. But remember, we have three groups. So we have clinical Harris too. And we can as I told you, we can calculate the semantic similarity using different techniques. For example, we can use different window sizes and then average all the averages. So for example, we can calculate the semantic similarity, correlative semantic similarity between 4 words, consecutive 4 words, and we move this window through the speech, and then we obtain the average of this. And in the left, we can see that as long as the word window become larger, this average semantic similarity approaches to the average semantic similarity in the affinity matrix. So in this matrix, when we have all the words, content words compared. So using this measure of the semantic similarity in the metric, in this affinity matrix, we found that only clinical race was higher in semantic similarity than controls. But if we look at the graph from the left, you can see also that even if schizophrenia produced a higher semantic similarity and it was not significant, along the whole windows you can see consistency. So it's always higher depending on the window. And there is something that we have to explore here because Clint Harris is crossing this line. So this is something to explore next, but we don't know why is happening this. Okay, so just focusing on schizophrenia controls, we can see some relationship between the number of entities, for example, or the number of MPs and the semantic similarity. So in the left, we have the density of MPs. So it was higher in, we already know that, higher in schizophrenia and controls, but also the density of number of entities. So the number of entities, if you remember, sorry, I should say here is the number of recurrent entities. So if you remember the nodes, these correspond to the nodes with with recurrences. So here, the density of the recurrent entities was also higher in schizophrenia than controls. And we have some correlation between the density of recurrent entities. So how, for example, if they are describing something, how many things they describe and come back to them. This is correlated with semantic similarity. So here, what I want to say is something to explore. Maybe because of the same reason we have a widening of the referential chain, because we have larger distance, topological distance between entities. Maybe the same reasons that leads to that leads to an increase of semantic similarity. So we wanted to study the same ideas, but with a different task in a different language. And we are doing this analysis in German. So this is data compiled and provided by Professor Thilo Gerha and Friederike Stein from the Department of Psychiatry of the Philipp University of Marburg. And we have a spontaneous speech dataset, so it's completely different, of using thematic perception test, using 4-picture and 3-meter speech. We have 43 clinical stable patients with schizophrenia spectrum disorders, 39 patients with major depressions, and 43 healthy controls in this data. So you can see here, these are the pictures they are describing in 3 minutes. So the first one, second, this has the number 4, and this is the number 6. Okay, so the results you are going to see here. To the left, you can see just if there's significant increases, and there are not significant increase if we calculate the average of the semantic similarity across all the tasks, all the pictures. But we also run a mixed effect regression, and to the right, so you can see to the right this, and you can see if we run this mixed effect regression, we observe significant difference in between schizophrenia and healthy controls in the mean of semantic similarity. In this case, using consecutive words. And you can see there is a picture effect. So, for example, in picture 2, you can see the effect is larger than in picture 1, for example. So you can think that maybe taking the average of these is not doesn't give any result, but when you control by picture, you obtain result, and this is saying something. The same if we calculate, for example, the standard deviation of semantic similarity. So its standard deviation was significantly lower in schizophrenia than major depression and than controls, but also we can see here a picture effect. So this increase in semantic similarity and this decrease in the standard deviation says something about, again, the shrinking of semantic space, because they are not crossing a larger distance semantically. Also, you can calculate the range of semantic similarity. So this is the maximum semantic similarity minus the minimum. And we also find significant difference between schizophrenia and controls. But again, this picture effect. And using affinity metrics of, you remember, we have the matrix of all the content words, and we compare all the content words, and then we obtain the average of these. We also found significant difference, an increase in mean of semantic similarity in schizophrenia. Again, also a picture effect here. So some other things important here are, if you look at the graph to the right, you always will see that the major depression group is in between schizophrenia and controls. And then we calculate some other measures using semantic graph. So I will introduce briefly here the idea of semantic graph. So in semantic graph, we also have all the content words for the speech, but we obtain the semantic similarity between all pairs of words, but we create a graph based on a dynamic threshold for each speech. And then we obtain a speech graph, containing only semantic words, only content words. And we found, again, significant difference between schizophrenia and healthy controls in the average clustering coefficient. So this, again, is saying something about when it's saying something about the shape of this graph, is also saying something about this idea of shrinking of the semantic space. So it's complementary to the other measures. Then some other non-significant difference or weakly significant difference between schizophrenia and controls in the average closeness centrality of the graph, and weakly significant or no significant difference between schizophrenia and controls in the density of the graph. And in all these measures, we also found this picture effect from before. So as a summary, at the beginning, I was talking about referentiality, and then how this referentiality could be connected with semantic similarity measure or different semantic similarity measures. So the idea is there is a connection between the referential structure and the lexical conceptual structure. And recurrence and the MP production could be viewed as causing an increase in semantic similarity and larger topological distance, at least in the Chilean data. Also, some key idea I want to share is loosening of associations may relate to increase in semantic similarity instead of a decrease in these measures. And the use of semantic graph, the last graph, to calculate semantic similarity leads to some similar results. And an important message is we have to control for picture effect. This is, at least in this data, turned out to be important. So that is the presentation. Thanks for attending.
Claudio. Thank you so much, Claudio. And I think we can pass Rui at the end of the whole presentation. I can take all the questions and we can pass the discussion part. Rui, are you ready?
Yep, thanks.
Please.
I share my screen. So can you see my screen now?
Yes, but it's again not in the, now it's okay, yes.
Oh, okay, thanks.
Mm-hmm.
Okay, so thanks everyone for coming. So today I will be talking about, so as Claudia has already talked about the concepts of semantic space, semantic similarity, coherence, etc. I will talk about some cross-lingual evidence and how we can go beyond semantic similarity to explore the semantic space. So most of the results are based on these London datasets where people collected the 1 minute picture descriptions from 3 TED pictures. And datasets collected in London, Ontario, and provided by Lena and Valia. Many thanks to their generosity. This data is composed of 4 groups: controls, high risk, first episode, and chronic. And here I present the clinical scores and demographic of them. So at the beginning, I still talking about the traditional measures of consecutive semantic similarity as a measure for coherence traditionally thinking. So consecutive semantic similarity is measured with this static word embeddings. By static, I mean each word has the same embedding regardless of their context. So think about the word man. In a sentence, the man went to the bank. And in a sentence, a man is an adult human. These 2 sentences have completely different meaning, but they share the same embedding in these static language models. And with this static word embedding, we can have this famous formula, kin minus man plus woman equals to queen, measured by the cosine semantic similarity between the word vectors. And here I use the language model called FastText, which can capture the semantic word embeddings and capture the semantic word embeddings of the words not in the vocabulary. So here we have the results. So the two plots are the results from the London data set we just showed. We have the increase of fast text-based semantic similarity in first episode schizophrenia in both my study and in Maria's study in an overlapping sample. And in another Chinese study, where we focus on the nouns in the Chinese study, Zhang Han and I did the study together, and we found also an increased semantic similarity in schizophrenia. And as Claudio has just shown, there is an increased semantic similarity in high-risk schizophrenia in Chilean semantic free speech, and there is also an increase in semantic similarity in German schizophrenia. And in previous study, although we know some previous studies found a decreased semantic similarity, there are also some previous studies found increase in semantic similarity in Russian written text, in Danish, German, and Mandarin picture description, and in a Cantonese verbal fluency task. So all the results we just shown points to the fact that instead of decreased semantic similarity, what has been thought as a evidence for loss of coherence for several years, we also observe increased semantic similarity in a lot of results. And actually in the results we have in our lab, we always observe increase. So here I give this question: does semantic similarity really means coherence? I would say no. I'll give you an example. The fox jumped over an apple. This is a coherent sentence. But if we order the words in the order of semantic similarity, so we pick up the first word that's exactly the same, the, and we pick up the words both similar to the, this is M, and over is the most similar to M in a leftover word, fox more similar to over, jumped more similar to fox, and apple similar to jumped. So the and over fox jumped apple. This sentence has very high consecutive semantic similarity, but it's not coherent in any sense. So maybe we need to be faithful to what we are measuring. We are really measuring semantic similarity when maybe we're not measuring the coherence. And the possible metaphor for this semantic similarity could be the semantic structure. So the structure of semantic space. A higher semantic similarity may indicate a shrinking semantic space, while a lower semantic similarity may indicate an inflating semantic space. But semantic similarity itself has some limitations, and we need to go beyond it. Because first of all, those semantic similarities are only at word level. So we only compare word to word semantic similarity using those traditional measures. We're not comparing sentence. And when we comparing words, we did not take the context of word into account. So if you still remember the two examples I just gave, the word man has exactly the same embedding in the man went to the bank, and a man is a adult human. So the two men share the same embedding, but actually they do not. And the semantic changes with the context, with the word's co-occurrence with the man. So we need to take a context when we model word meanings. And also semantic similarity also gives just a limited view of the semantic structure. It's only about the distance between consecutive words, and we may have more sophisticated measures than that. So okay, here I'll give you an example. Wonderful alternative is to use contextual word embedding to include context in model word meaning. So one option is to use BERT, which is a mask model. It predicts the masked words. For example, here, the man went to the store. The BERT predicts the masked word as went using a decoder, encoder, decoder structure. Well, in these structures, in BERT, it contains 12 layers in this encoder, decoder structure. And the first and second layers are sensitive to the superficial features like length of a sentence. And the intermediate layers are sensitive to the syntactic structures, especially formal syntactic trees. And the later layers are sensitive to the semantic structure. So this BERT could be taken as a integration of the meaning of the information from both semantic and syntactic. And same thing as GPT, but GPT is different from BERT in a mask sense. So GPT not only masks the word itself, but also the words behind, also the words after it. So when we predict the man went to the store, we predict the word mask word as the went. we only use the information from the previous, the man, not afterwards. So, okay. So as you may have noticed, in fast text, I'm saying the model is modeling the word meaning using vectors. But here, using BERT or using GPT, we are not really modeling the meaning using vectors, but we are doing predictions of the masked words. So using BERT and GPT, what we can really get is actually the word probability, and it's grammar related. Because as I told you in the layers here, we have the layer sensitive to syntactic structures, and we have a layer sensitive to the sentence length. So these probabilities are grammar related, and you can use this probability in an information theoretical way. So using entropy to measure the entropy from the probabilities. And cross entropy is one information theoretic measure that measures the prediction of these models from the observed samples. For example, if the bird predicts this sentence, the man must to the store, as the man came to the store, then we can measure the difference between the man went to the store and the man came to the store, the observed sentence and the predicted sentence, and the difference is measured using cross entropy. And in NLP, we describe the exponentiated value of cross entropy as perplexity, showing how perplexing a sentence is, because this could be taken as a measure for how the observed sentences deviates from the sentence produced by typical population, because these two models, BERT and GPT, are pre-trained on data from typical population. So, okay, here goes the results. Using BERT to measure semantic similarity, we found an insignificant decrease. And this decrease is like marginally significant in this case, as opposite to the significant increase we measured using fast text. So we found completely different stuff here. And the perplexity significantly increased when we measured with BERTs. And this increase of semantic perplexity is confirmed by using another model, GPT-2. We also found an increase of semantic perplexity. So which means, although schizophrenia people created sentences using more similar words, they are creating a more perplexing sentences using the more similar words. So which means we can expect the increase of semantic similarity in schizophrenia goes along with the increase of perplexity in schizophrenia. So which could be intuitively explained in this way. In psychosis, different areas in the semantic space may not be far enough, so they are not clearly separated to create a sentence that has a low perplexity. That is understandable. So this is one alternative, what I just showed, to go for contextual word embeddings with a contextual semantic similarity or the contextual perplexity from the contextual language models. Another option is to go from a word level to sentence level. So we are not measuring the consecutive semantic similarity between words, but between sentences or between utterances. This approach has been applied in Morgan's paper. They use averaged word embedding from word to vec to represent sentence, but this is considered not as a good representation because the average word embedding does not has really a clear meaning, and it has been empirically proved to not perform well in semantic similarity evaluation tasks. So people developed several models to represent sentence meaning, and here I pick up two models. One is inference. Inference started from a context-free embedding, but in its own architecture, it has some bidirectional long-short-term memory layers to include some contextual information, but not as much as is done in BERT, because BERT has a transformer structure. So in inference, we have a sentence embedding from a context-free model, and we use the inference from fast text. And we have another model starting from BERT, that is sentence BERT or sentence transformers. It started from the pulled output of BERT, but it is trained specifically for sentence similarity comparison. And these two models are considered to be a better sentence representation models than the averaged embedding methods. And use these two models we found there's a significant increase of sentence level similarity in the first episode of schizophrenia. So here we have again the evidence of shrinking semantic space by the increase of consecutive semantic similarity at the sentence level. And we have additional information from Turkish data. So this is from Emily Bola's group. They're using bird to measure the local consecutive semantic similarity or the global semantic similarity, which means OPEL similarity in Turkish schizophrenia datasets, and they also found a higher semantic similarity in their datasets. Okay, so then the two measures we were talking about, word level or sentence level, they are all within task. But remember, the task we have is a picture description task, which means we may go beyond the text. We may go beyond the text to the stimuli itself, to compare the text to the stimuli. Because what we are measuring is a semantic space as a response to a certain stimuli. So here I use CLIP. This is a language model that can measure the semantic similarity between the picture and the text. For example, here in this picture, we're comparing playing music and playing sports, and playing music is much more similar to the picture itself than playing sports. And also in this example from our London datasets, the Dr. Sun shining this down has a similarity of 0.218 to this stimuli picture from the top pictures. And in London sample, we found that the clip-based image text semantic similarity significantly decreased in first episode schizophrenia and also in clinical high-risk group. So which means that it deviates more from the picture compared to controls. And we have additional evidence from one study by Sunny Tang, which is somehow different from our design. So we use the picture description task. In Sunny Tang studies, they use the interviews, so they measures how much differences there are between the response sentences and the interviewer's prompts using birds. And they also find that schizophrenia group, the blue lines here, has a larger differences from the prompts. So they also deviates further away from the prompts. Okay, so what we were just talking about are all based on similarities or word level probabilities. So the first text consecutive semantic similarity, the non-contextual one, the contextual semantic similarity, the semantic perplexity, and the sentence level semantic similarities. They're all based on semantic similarities. And semantic similarity itself are just about how similar are those consecutive pairs of semantic units. So this is a rather limited view, and a more comprehensive view could be using semantic graph, which Claudio had just mentioned a little bit. And the idea of semantic graph is developed inspired by the functional connectivity analysis in brain fMRI. And using semantic graph, we aim to represent the topology of the semantic space using a graph measure. To the left is what we did in fMRI canonically. We're using the functional connectivity arrays with the functional connectivity matrix from the time series to have this thresholding matrix, and this thresholding matrix represented as a graph. And in language also did this. So in this example sentence, the fox jumped over an apple. We have this semantic similarity matrix. This is all connected with thresholded matrix to make this sparse matrix for a graph, as you can see here. And here we give an example from our Mandarin Chinese datasets. This is a semantic graph from the real discourse. And we extract the small word properties of the graph. We focus on the two parts of the small word properties, the integration using shortest path. So characteristic path length, global efficiency, closest centrality, density, etc. And another aspect, the segregation of the graph. So whether there's a modularity represented by a triangle in the graph using clustering coefficients or transitivity. So the nodes in the graph can be defined not only by the words, but also utterances. So we use data at two levels. One level, we use the words, the content words, nouns, verbs, and adjectives, which we describe as lexical categories in linguistics. And another level is utterance. So we have another graph of utterances in a discourse. So in a London sample, at the two levels, we observe similar patterns. So for the word-based graph here, which I begin by FT, means fast text, there's a significantly higher centrality, significantly higher global efficiency, which means the graph is larger, has a longer shorter distance. And we have insignificantly higher clustering, so more clusters but insignificant. And these two together forms a effect of lower smallness by sigma, by the smallness coefficient using sigma coefficients. So the graph is less centralized and more sparse. So this is consecutive to the shrink space. No, the graph is more centralized. Sorry, has higher centrality, so more centralized and more efficiency. So the graph shrinks. So which goes in line with the idea of shrinking Smith space, and there are more clusters there, and these two forms a imbalance in the smallness. And such shrinking Smith space, such shrinking graphs is also observed at utterance level using sentence bursts, as measured here. Significantly higher clustering, significantly higher global efficiency, insignificantly higher clustering, and significantly lower sigma, lower smallness coefficients. And this pattern is also observed in Mandarin Chinese study when we use the noun phrases as a node of the graph. We found significantly higher centrality in controls. The t-value means the difference between controls and schizophrenia using controls minus schizophrenia. So negative means higher schizophrenia. So higher centrality, higher efficiency, and shorter path lengths, and higher clustering, insignificant, and lower smallness. So all these points, so all these measures we have now points to the fact that we could have shrinking semantic space in schizophrenia. And in actually all data sets we have in our lab in Chilean Spanish, in Germany, in English, in Mandarin Chinese, all the tests we have seen now, we all observe a shrinking semantic space. So finally, I give you some take-home messages. We always have increased semantic similarity, significant or insignificant, showing a shrinking semantic space, as I just said. Secondly, semantic similarity gives only a limited view of the semantic structure. We need to expand that measure. We can go to contextual word-to-word similarity. We can go to perplexity. We can go to the sentence level similarity. We can go to picture text similarity. We can also go to the semantic graph, as I just mentioned. And then finally, the increase of semantic similarity in schizophrenia is accompanied by the increase of semantic perplexity. So when we found more semantic similarity or we found higher semantic similarity, it does not mean that they are more coherent, but it could mean the opposite. They are less coherent, or they have a loosening of associations, as cannot be described, because of the increased perplexity. These two can actually go together. So that's all my presentations. Thank you very much for listening, and I look forward to your comments and questions.
And thank you so much for all these great presentations. And we can pass the discussion part. You can raise your hand, or you can write your question in the chat box. I can wait, whatever you prefer. And sorry, by the way, I lost my connection. Firstly, I saw Natalia wrote something on chat box. Right now, I cannot see it. We can, I think, start with the chat box, if it's okay for everybody. Then I can pass to people raise their hands.
Okay, I can ask Claudio. First of all, I want to congratulate Claudio. It is a beautiful paper. I read it with enthusiasm. It was really nice because particularly, I wanted to do something like that in the first idea that I have for my paper. So, but it was really challenged like 10 or 15, almost 15 years ago. So it is really nice to see it. But when I was working for the first time with this kind of idea, I faced this challenge that sometimes I could find like new pronouns. As I'm a psychiatrist, I didn't know what was a new pronoun. I had to call my colleagues in the linguistics, but it was something really more frequent in the psychotic speech than in the controls. Like they are referring to someone that it's not actually mentioned before. Like they are watching me. Who are they? You didn't talk about they, you know, but they're using all the time this new referential. So how to deal with this new referential? This word would appear without referentiality. It would be discarded. How to deal with that? This is the first question. And the second question, it's more about details, how to deal with graphs. So one, and maybe this I can, if you allow me, Tucci, I will also ask the same question to Rui, because one thing that I faced it's really challenging also, it's to have a large amount of words to perform a really complex graph. When we are trying to use attributes like clustering coefficients, density, and average shortest path, we need to take this into consideration. There were small words, for example. It's an assumption that are made for complex networks. And sometimes we have such a few words from a narrative, you know, and like 30 words, 40 words. It's not complex actually for this graph. So I wanted to know how to deal with that, because for Claudio, when you were defining your node as num phrase, it reduces the amount of nodes that you have in your graph. So how to deal with that, and to consider this. And my question is, what is the mean number of nodes that you consider in your graphs? There are dozens, hundreds, thousands of nodes, or more or less, just to have a picture and to trying to interpret your data in clustering coefficients or models like small word networks, things like that. Thank you.
Okay, I can answer now, right? Okay, thanks for your comments. So about no pronouns, I was thinking like no pronouns as not being in the speech. So grammatically, they are always there. So you can identify it by the verbs. For example, at least in Spanish, you can say, okay, it's talking about a man. So you can look at it, and we annotate manually these null pronouns, because what matters to us is the topological distance between different nodes. It doesn't matter if it is more to the left to the word, more to the right to the left. The position, the exact position of the noun phrase, it doesn't matter, unless there are two pronouns in the same utterance. And in those cases, I had to make a decision to what put first or what put next. But about the anomalies in referentiality, for example, when they say they and we don't know what they are referring to, I saw, at least in the interviews I was reading, not so many cases of this pyramidal anomaly. or not being clear what they are talking about. But in those cases, when I saw this, I had to decide too. So other, maybe in some very specific cases, I had to eliminate it or say, yes, this is a noun phrase. I don't know what it is. But they are clearly marginal, not so important to the whole analysis. And yeah, the other question is more difficult because in this case, in the interviews we have many words, so they have around 1,000 of words, and yeah, when we reduce all the words to noun phrases, we obtain around 100 of noun phrases. This is the order of, but it's very variable. So some people, even speaking many words, they produce more or less noun phrases. So it's variable. That is the order, around 100. And also the number of entities, for example, was around, on average, was 10 entities by speaker, but some of them produce 20 recurrent entities, some of them produce 2 recurrent entities. So an example is one patient was talking about the mother and the father, and nothing else. So every other noun phrase was incidental, and it appeared again. But those cases, yeah, this happened, and we try to control. I mean, in this semantic graph, we think that we are matching by the number of words they produce, so shouldn't have a problem there. But in semantic graph, we have something different, because in semantic graph, it's like a complementary graph, because in semantic graph, we don't have noun phrases, not necessarily noun phrases, because we have content words. So some lexical head of the noun phrases can be content words, but some other, for example, pronouns are not there. These are things we have to continually thinking about. How to control for that. Yeah, and Rui has an answer also for that.
I want to answer about Natalia's question on the number of nodes in the graph. Yes, we have so far we have shown, Claudio and I have shown the semantic graph has several levels. The level of noun phrases, level of words, the level of content words, I would say not words, content words. We only include the noun, adjective, and verbs. And the level of utterances. For sure, at certain levels, we will have very little number of nodes. For example, at the utterance level, we always have like 20 utterances, 15 utterances, or at most 30 utterances. That's the most. But personally, I don't think that could be a problem, because due to time limit, I didn't specify how I do the thresholding just now. So this idea comes from the functional connectivity analysis of small witness graph, and the thresholding is a dynamic thresholding way to make the graph, to ensure the graph has small witness properties. So the method is to try out several thresholds from 0.05 to 0.80. So to threshold the graph by 5% to 80%, to see the least, the smallest threshold, which can make the degree of the graph larger than logarithm of the number of nodes. So in this way, we adjust the thresholds based on the number of nodes. And this ensures that the graph itself has the smallness properties that we can measure, that the centrality, the clustering, the smallness coefficient, something like that. Yeah, so this deal with the number of nodes. So I think here we don't need to worry too much about that, because I've seen papers in functional connectivity that use only 8 rows or 6 rows for those graphs, and they also work pretty well with that. So I think this is like
really nice.
solvable
Really nice
in
idea.
the methodology. Thank you so much for that question.
Thank you. I would love if you could share this information with us. Thank you very much.
Yeah.
Yes, in fact, I was the first, I think, to ask the questions. If you allow, I really want to ask questions to Claudio and Rui also. to moderate effectively later. And Claudio, I really amazed with your study, because even in our previous discourse session, for instance, in Toden language index also, we are using thought cards, thought pictures, for instance. And I remember every time the stimuli can affect the results. At least it's my, it's like a hunch maybe. But when I taking the data, I see this. For instance, when, there is a card, I think it's about an actor. Every time in Turkish sample, schizophrenia patients, except from their symptoms, they call this card like he is Atatürk. Atatürk is the founder of the Turkish Republic, but normally he looks like an actor in American movies. But every time they were pretty sure, all of them almost, really, they said he is Atatürk, and the derailment start to, occur in this sample mostly. It's like the trigger of these symptoms in language. But in there is a boy in front of a cottage, a poor boy sitting on front of the cottage. Every time I took really, the number of the sentences and complexity is really less in this picture, specific picture in thought. And I think when we take care of these pictures and stimuli power, while taking the data, even we can take more specific language-related infos, depending on even symptoms, much more valuable information from language, depending on the specific state of the schizophrenia, I think. When we use the critical stimuli correctly. That is why I believe that this study is really amazing for me. Every time I come across these things, but I didn't prove this. Right now I can see this thanks to you. And when I come to Rui, it's just a comment again. For instance, in MRI studies also, diffusion tensor imaging, functional MRI, we are calculating really complex things, basically, like brain or higher level cognitive functioning things like language. And we are finding some significant things, but I believe the statistics and the tools, like for instance, BERT, GPT, GLOBE, many things, we can calculate semantic similarity. Every time it gives different results. Like in MRI studies also, when you think, for instance, think about, you can want to take a look causality, all the models can give different results. And I started to see this in natural language processing studies also. When I check the studies, we can calculate we can using some measures, we can take results, and every time results really could be changeable depending on measures and advanced statistics, for instance. That is why I think both of your presentation and your studies is really helpful for us, I believe. Thank you so much. It's just a comment. And in chat box, I think Jan has a question. Maybe Jan, would you like to read?
I think Valentina also had one in there as well.
Oh, sorry, Valentina. Yes, I missed it. I didn't see it. Yes, Valentina is
sorry. I would wait with no problem, but my free time expired, and so I want to drop my question quickly till my daughter can
yes,
resist.
Please, sorry.
Yeah. So, it's all again for Claudio. Thanks a lot for the presentation. I really enjoyed it. And I have a typical linguist question, which is whether you control for the grammatical rule of the different NPs, because I assume that this might play a role. And the second question that I have, it's somehow related to the comment that Brian McWhinney added in the chat, going back to Bloiler and loosening of association. I wonder whether you found, if you said it, I missed it. Did you find some direct connection between the increased use of NPs and symptoms, such as, for instance, disorganization or PANS items? Thank you.
Okay. Can you rephrase in a way what you refer when you say controlled by
Well, I assume
kind of
that
NPs?
Control or check the different function of the NP. Some might be subject, some might be object, some might be indirect objects. I don't know, unless you limited the function of the NPs, and if you said this, I missed it, I'm sorry.
No, it's okay, it's a perfect question. Actually, at some point, we wanted to make a final distinction between different NPs, but the question is, what distinction make? For example, I was counting at some point only first person, so to see if the increase in first person is important or not. But for clarity, we opt for having all the NPs in the same category and then look for distinction, but it's something to still do. So it's something that we haven't addressed totally. But yeah, but it requires some more annotation work. And about the symptoms, no, we don't have any, at least in the Chilean study, we don't have any relation between the increase in noun phrases or the increase in density of entities with some symptomatology. Yeah.
Thank you.
Thanks. And right now, I think we can pass Jan.
Yeah, thank you for the very interesting talk. I just have a clarification question. Maybe you probably explained already, if you don't mind repeating. So I just wondering what you mean by shrinking or inflating of semantic space. Is this term associated with distribution space? What are the key features of a shrinking or inflating semantic space? Can you say a bit more? Either Ray or Claudio or both. Yeah.
So I think I will answer this question, but before I answer, I would like to confirm with you that whether you mean the distribution space in the sense of machine learning. So you mean the distribution of those like word vectors or like high dimensional vectors in the space, and those high dimensional vectors form the space. Is this what you mean?
Maybe perhaps I guess just in general, would appreciate some more clarifications on that.
Okay. Now I think I understand you now. So I think you mean the distribution space by just like distribution of items and whether we're measuring the items. And my answer would simply be yes, yeah. So that is also the idea of semantic graph. So when we are measuring consecutive semantic similarity, we are measuring the distance between consecutive items. And if the distance between those consecutive items becomes shorter, then we think the space shrinks because the distance of two extremes shortens. So this is actually the shrinking semantic space is a metaphor, and this is the idea of that metaphor. And then I think this metaphor so the concept of semantic similarity may not be enough for us to see the semantic space as a whole and to capture the shrinking as a statement of the properties of the whole space. So I introduced a semantic graph inspired by the functional connectivity measures using the graph-based measures, using word-to-word similarity metrics, because the word-to-word similarity matrix is like a distance between all pairs of the words, a measure of that, and we thresholded out those insignificant ones as we measured with the thresholds. like lower ones, and then we only maintain the higher ones. And then we have the graphs to show the topology of the whole semantic space, and we compute the small units properties of the graphs, like centrality, global efficiency, shortest path length, clustering, to show some properties of the graph, which can give an additional information to the shrinking or inflating based on those properties. I hope this answers your question.
Yeah, that answered my question, I think. Yeah, thank you.
Thanks. Thank you.
And sorry, there are many questions and debates in the chat box. I try to follow them. Yes, right now I think Jean-Pierre a question, and already Sunny answered this question also, I think. Jean-Pierre, would you like to read your question?
Yes, this is a question for Claudio, and thank you very much, by the way, Claudio, and also your colleague, Rui, for really very interesting presentations. More on a conceptual level, I was wondering, between the two sort of issues which you have been referring and investigating, the semantic similarity and also the referential derivative, what do you think is primary in the loosening of association phenomenon, which we all know, is sort of a hallmark of schizophrenic thinking? Is it sort of an equal level, or is one kind of more primary and the other one might be secondary?
Okay. If I have to answer this, I would say I don't know. But my feeling, my intuition is both things are very related. It's very difficult to know in which way both things are interacting. And some other intuition I have is these things are co-evolving in time. So as we don't have any progression of the illness, we cannot know that. I think we should, in order to know how they influence each other, we need a long run of the progression.
So in other words, you would like to see a longitudinal assessment starting with clinical high risk and then moving to first episode and eventually chronic.
Yeah, exactly. I think both things are very related. The semantic side or the grammatical, even if there is no clear how they are really a separate thing, because this is for us to study, we make this distinction, but actually maybe there is no such a distinction in the brain. So maybe by looking in an longitudinal study, we could assess better if something is more grammatical or more semantic in such a way.
Thank you.
And I think Natalia already asked Rui's question and comments. Amelie, would you like to ask your question, read your question? We cannot hear you, I think, Amelie.
Can you hear me now?
Yes, we can hear you right now.
Sorry, I was just I just had small details, questions, trying to I was trying to reflect on how this could these graph analyses based on non-phrases and on the reference could be applied to the data that we have in my lab, where we have stories with either one or two characters, and their characters are sometimes both male or sometimes both female, sometimes a male and a female. But I was just thinking about some details that we see that sometimes people will refer to a male and a female character as the couple, and then it sort of refers to the man as well as the woman at the same time. And Claudio answered that they would consider the plural as a third referent as a third referent and not combine it with either one. And I had the other example of if someone says like his wife, in my mind, his wife refers to the wife, but refer to him who's the possessor of the wife. And like another example of if I was to like track, I wouldn't really know what like to do. Is just another example, but it's like really picky details. Like it was more of my attempt to see how we could adapt those techniques to the data that we have, because I think it could be very interesting, like especially that the tasks that we have were specifically designed to have like specific like referential moments. So like the same characters are introduced, then maintained in focus, then there's a switch to a second character, then the second character is maintained in focus, then a switch back to the first, and then a maintain of the first again. So there is a very specific sequence, and characters can be mentioned more than that. But there is like studies showing that like when in the images that the stories are based on, when a character is visually in focused and more active, people naturally select that character as the subject of their sentence, as the grammatical subject, and that's the case like 99% of the time. They can be anyway. So like it's just something like I don't want to bore everybody with the details of that, but I'm just trying to like tell Claudio a little bit more about our tasks, so that like if you're ever interested in like trying to like think about it, like something that could be interested, like I think our data are very well suited to look at like reference to characters anyways, because it's like very systematic between the participants, and yet very like different between the participants, like as well.
Claudio, would you like to add something more, or already answer, I think?
Yeah, maybe just something brief about the different pictures and the focus on the characters there, because what motivates me to relate these semantic similarity measures in this test is relate this with the referential structure, is because I have if you remember the graph, you can see there are differences in the picture, so it's a picture effect. So maybe the pictures, as they are showing some specific characters, this relates with the entities and the characters they produce in the speech. So I think there is something important to look at there, as opposed to other, for example, free speech, like in the Chilean data.
Thank you, Claudio. And there is, I think, Brian question. Brian, would you like to read? Or if you want, I can. Is Brian here? I think no. If I can read, already we are recording. Wasn't Lola referring to syntactic associations rather than word similarity associations, as in semantic network theory? If so, isn't that really close to greater perplexity? I think Lena answered it also.
Well, I think Wolfram was typing the answer at the same time. We probably gave the same answer. And historically, Wolfram,
Yeah,
you're right.
Sorry, yeah, I see right now. Wolfram also.
Well, I had a very small point to make if the chat box is done. I just wanted to thank Wolfram and the group to start with, because this is a very nice example of bringing data from various sources and really making questions relevant to schizophrenia, really deep questions that we are thinking about. answered using data sets. So excellent, and congratulations everyone for this work to start with. My quick question was around the whole idea of mental lexicon. How is it represented? Because when we talk about this concept shrinking and clustering of space, it could also be that there is no shrinkage as such, but access to this lexicon is somehow different in patients compared to healthy controls. Again, it could be a debate that can extend for half an hour. I don't want to take all of the time given the minute, but maybe we should think in terms of neural correlates, whether we can study this, whether we can make more sense of the statements that we make based on neural data.
Yes.
And I think my question that
Yes,
was somewhat
Sunny.
related to that, and so I think well, anyhow, Lena, you were talking about like difficulty accessing lexical concepts. I was also thinking about the fact that there's clinical heterogeneity as well as like temporal differences. There's also like shifts across time in individual patients as well. And so I'm very convinced by what you've shown in terms of the increased semantic similarity and potential shrinkage, but there also is work in some samples showing the opposite with at least very similar methodologies. And I wonder if in addition to the different, like the nuanced linguistic ways of looking at it, if also clinically could be some nuances there in terms of being, samples where like negative symptoms and, limitations in ideational richness might be more predominant versus other samples where there's a more active, like acute and, almost manic type psychotic presentation, if that could play a role. And I'm also thinking, I guess I'm not sure if there's an answer at this point, but in terms of neural correlates and whatnot, I also wonder if these are really like the ways that we're talking about this, we're kind of treating them like almost like traits. Like this is something that the ways that we've been discussing it, it's almost like a static, difference that brains are experiencing, but I wonder if we also need to think of it potentially dynamically as functions that can work well or become impaired at various points.
So I could say something about that. So yeah. So I think first, thank you, Lena, for saying such nice words. And I think the first thing I have to answer is the access to lexicon. If I don't remember, you mentioned this in the talks. And just in another study of mine, I found that access to lexicon is related to syntax. So the formal syntactic rule serves as at least correlates with the access to lexicon, access to our lexicon memory, and that does not significantly different in our London sample. So syntactic depths. So they have relatively retained the syntactic proficiency in the first steps of psychosis in our sample. And if we really think syntax as a one way of access lexicon, then in this sense, the access of lexicon does not really impair in that sense, but this may not be a very valid argument, but just a prompt for thinking a problem. And another response is to the semantic similarity as a trait or as a dynamic features or something like that. We don't have longitudinal data now, so I cannot say sure from our samples, but from one of Malia's research, I think they use an overlapping sample also from the long data sets, and it's from Malia Alonso from Lena's group. And in that paper, they show that semantic similarity has some longitudinal effect in that paper. And also in a Cantonese paper using word fluency, not PK description, but word fluency, they also found that semantic similarity has an effect on the psychosis. So the semantic similarity is insignificantly lower, but very similar to controls at the baseline of the first episode. So when they first have the psychosis, there's some similarity in the verbal fluency task. Remember, the verbal fluency is very different from picture description as a spontaneous speech. So the similarity there is slightly lower, but it grows very quick in the 6 months after the first episode. And after that, after 6 months, it's higher than controls. And the speed of growth is significantly higher than controls. So based on these two studies, I think it could be a dynamic features for how speech fluctuates in the cognition in psychosis.
Yeah. And that's really fascinating. And it's not the only example of certain findings that where we find the opposite effect in clinical high risk populations, we see in more chronic schizophrenia. I think, so compensatory mechanisms have sometimes been proposed for things like this.
Yeah.
Sweeney, can I just mention along your suggestion, I would also maybe recommend to Claudio and Rui if they could subclassify their patients they take into their samples in terms of predominant negative symptoms or predominant positive symptoms, because that, when we talk about schizophrenia sort of as a kind of a global concept, that's highly heterogeneous, obviously. And we need to subdivide it clearly, because we have now ways of subdividing the presentation much better than what we used to. So it might be helpful, because you have speech problems which are very different between an acute and positive patient versus a chronic negative symptom patient. You have poverty of speech. You have also a reduced lexicon, et cetera. You have the speech pauses, and all of that may play a role in your measurements.
I think so too. Che had to go to a clinic, and we're certainly over our scheduled end time of 10:30, but there is one more hand up if the speakers are up for answering one last question.
Thank you for the wonderful talk. I just wanted to follow up on the effect of different stimuli on language behavior and the measures that you could extract. And I can think of one paper, I think it was from Natalia's group, when they saw that the valence, actually the emotional valence of the picture which is shown has something to play with the disorganization in speech. So do you have any preliminary observation related to the what actually derives the different linguistic behavior associated with different pictures, and if the emotional valence versus the complexity of entities within the picture is something that driving the effect, how do you think the semantic shrinkage might be related to the emotion which is in play while describing the pictures?
Yeah, I think by now we are still exploring why we have this difference, but I don't know in which way we could control for this emotional balance. So if you have any suggestion, it's great.
I think the pictures, by the nature of what they represent, were classified into neutral, negative, or positive emotions. And then I think in that paper, they showed that where we have negative emotions, we can see disruptions in the speech graphs. But is it right? I mean, Natalia is here.
It would be interesting.
Yes. So we measured the amount of words classified as positive emotions or negative emotions using the LILC, the linguistic inquired word count. Yes.
I think I'm referring to another paper where you had different pictures associated with different emotions as your stimuli.
Oh yes, I also use it, this protocol that it was based on the IAPS database. So they had this image database from the 90s. It's very old nowadays, but it's still very useful for the themes of the scene. So I collected some themes that were extremely positive or extremely negative, and I show it, or neutral in emotional valence. So I put the protocol with affective pictures versus neutral pictures. And then I had this positive images. For example, I have this assumption that the people would express the congruent emotion. So if it's a positive emotion, they should express somehow the congruent emotion. And I measure, and what I found is that only for the first episode psychosis, those ones that were able to express more the congruent emotion were those ones that were producing more connected narratives. But there were no association in the controls, only with those that were experiencing psychosis. The same, I think that like any narrative, even those, I like very much the idea to use the TAT pictures because they are very ambiguous, and they also could elicit some kind of emotions that we are not actually able to express in the beginning, but I think that we can also add this both analysis with different pictures as well.
I think if Amelie were still here, she would make the point that social and emotional kind of tasks and stimuli are really important for eliciting a lot of the changes and impairments that we find in schizophrenia. Anyhow, thanks everybody for sticking around. This has been a really fantastic presentation. It was really great to hear about both of your great work. And so, without further ado, we'll see you next time for our final discourse seminar of 2023. And please reach out to me if you guys have ideas and suggestions for 2024. We're still in the process of putting that together. All right. Thanks, everyone.
Bye-bye. Thank you, everybody.
Bye.